Welcome to Quantum, a channel dedicated to theoretical physics, with all its rigorous mathematical underpinnings and profound philosophical implications. John Bell was one of the greatest theoretical physicists, leaving a profound and lasting impact on quantum mechanics, particle physics, and quantum field theory. His celebrated Bell's theorem, revealing the deep constraints imposed by quantum entanglement, stands, as Henry Stapp described, among the most profound discoveries in science. In today's talk, we present Bell's famous lecture, Speakable and Unspeakable in Quantum Mechanics, which later gave title to his well-known book. In the first part, we deliver Bell's words faithfully. In the second, we offer our commentary, focusing not on his quantum foundations, but on his striking social observation, the sleepwalker metaphor, likening theoretical physicists to sleepwalkers moving confidently through conceptual darkness. Speakable and Unspeakable in Quantum Mechanics, John Bell. The history of cosmic theories may, without exaggeration, be called a history of collective obsessions and controlled schizophrenias, and the manner in which some of the most important individual discoveries were arrived at reminds one of a sleepwalker's performance. This is a quotation from A. Koestler's book, The Sleepwalkers. It is an account of the Copernican revolution, with Copernicus, Kepler, and Galileo as heroes. Koestler was of course impressed by the magnitude of the step made by these men. He was also fascinated by the manner in which they made it. He saw them as motivated by irrational prejudice, obstinately adhered to, making mistakes which they did not discover, which somehow canceled at the important points, and unable to recognize what was important in their results among the mass of details. He concluded that they were not really aware of what they were doing, sleepwalkers. I thought it would be interesting to keep Koestler's thesis in mind as we hear at this meeting about contemporary theories from contemporary theorists. For many decades now, our fundamental theories have rested on the two great pillars to which this meeting is dedicated, quantum theory and relativity. We will see that the lines of research opened up by these theories remain splendidly vital. We will see that order is brought into a vast and expanding array of experimental data. We will see even a continuing ability to get ahead of the experimental data, as with the existence and masses of the W and Z mesons. Perhaps this more than anything convinces us that there is truth in what is done. In the manner in which this progress is made, will we see again any elements of Koestler's picture? Certainly we will see nothing like the obsessive commitment of the old heroes to their hypotheses. Our theorists take up and put down hypotheses with light hearts, playfully. There is no religious intensity in it, and certainly no fear of becoming involved in litigation with the religious authorities. As for technical mistakes, our theorists do not make them, and they see at once what is important and what is detail. So it is another feature of contemporary progress, which reminds me of the title of Koestler's book. This progress is made in spite of the fundamental obscurity in quantum mechanics. Our theorists stride through that obscurity unimpeded. Sleepwalking? The progress so made is immensely impressive. If it is made by sleepwalkers, is it wise to shout, "Wake up"? I am not sure that it is. So I speak now in a very low voice. In a moment, I will try to locate the problem of quantum mechanics. But first, let me argue against a myth, that quantum theory had undone somehow the Copernican revolution. From those who made that revolution, we learned that the world is more intelligible when we do not imagine ourselves to be at the center of it. Does not quantum theory again place observers, us, at the center of the picture? There is indeed much talk of observables in quantum theory books, and from some popular presentations, the general public could get the impression that the very existence of the cosmos depends on our being here to observe the observables. I do not know that this is wrong. I am inclined to hope that we are indeed that important, but I see no evidence that it is so in the success of contemporary quantum theory. So I think it is not right to tell the public that a central role for conscious mind is integrated into modern atomic physics, or that information is the real stuff of physical theory. It seems to me irresponsible to suggest that technical features of contemporary theory were anticipated by the saints of ancient religions, by introspection. The only observer which is essential in orthodox practical quantum theory is the inanimate apparatus which amplifies microscopic events to macroscopic consequences. Of course, this apparatus, in laboratory experiments, is chosen and adjusted by the experimenters. In this sense, the outcomes of experiments are indeed dependent on the mental processes of the experimenters. But once the apparatus is in place and functioning untouched, it is a matter of complete indifference, according to ordinary quantum mechanics, whether the experimenters stay around to watch or delegate such observing to computers. Why this necessity to refer to apparatus when we would discuss quantum phenomena? The physicists who first came upon such phenomena found them so bizarre that they despaired of describing them in terms of ordinary concepts like space and time, position, and velocity. The founding fathers of quantum theory decided that no concepts could possibly be found which could permit direct description of the quantum world. So the theory which they established aimed only to describe systematically the response of the apparatus. And what more, after all, is needed for application? It is as if our friends could not find words to tell us about the very strange places where they went on holiday. We could see for ourselves whether they came back browner or fatter. This would be enough for us to be able to advise other friends who might wish to be browner or fatter about those strange places. Our apparatus visits the microscopic world for us, and we see what happens to it as a result. The problem, then, is this. How exactly is the world to be divided into speakable apparatus that we can talk about and unspeakable quantum system that we cannot talk about? How many electrons or atoms or molecules make an apparatus? The mathematics of the ordinary theory requires such a division, but says nothing about how it is to be made. In practice, the question is resolved by pragmatic recipes which have stood the test of time, applied with discretion and good taste born of experience. But should not fundamental theory permit exact mathematical formulation? Now, in my opinion, the founding fathers were in fact wrong on this point. The quantum phenomena do not exclude a uniform description of micro and macro worlds, system, and apparatus. It is not essential to introduce a vague division of the world of this kind. This was indicated already by de Broglie in 1926 when he answered the conundrum wave or particle by wave and particle. But by the time this was fully clarified by Bohm in 1952, few theoretical physicists wanted to hear about it. The orthodox line seemed fully justified by practical success. Even now, the de Broglie-Bohm picture is generally ignored and not taught to students. I think this is a great loss. For that picture exercises the mind in a very salutary way. The de Broglie-Bohm picture disposes of the necessity to divide the world somehow into system and apparatus. But another problem is brought into focus. This picture, and indeed I think any sharp formulation of quantum mechanics, has a very surprising feature. The consequences of events at one place appear to propagate to other places faster than light. This happens in a way that we cannot use for signaling. Nevertheless, it is a gross violation of relativistic causality. Moreover, the specific quantum phenomena that require such superluminal explanation have been largely realized in the laboratory, especially by Aspect, Dalibard, and Roger in Paris in 1982. For me, then, this is the real problem with quantum theory, the apparently essential conflict between any sharp formulation and fundamental relativity. That is to say, we have an apparent incompatibility, at the deepest level, between the two fundamental pillars of contemporary theory and of our meeting. I am glad, therefore, that in some of the sessions we will stand back from the impressive technical details of current progress to review this strange situation. It may be that a real synthesis of quantum and relativity theories requires not just technical developments, but radical conceptual renewal. Commentary on John Bell's Speakable and Unspeakable in Quantum Mechanics. Bell and the Debate in Quantum Mechanics. John Bell's work reopens many foundational debates in quantum mechanics, not by adding new formalism, but by questioning what we've stopped questioning. He challenges the arbitrary division between system and apparatus. He reframes quantum measurement not as revelation of reality, but as description of outcomes. He rejects the anti-realism of the Copenhagen interpretation. He supports the Bohm-de Broglie view, realist, deterministic, and non-local. He brings out the core conflict between quantum non-locality and special relativity. He engages entanglement as central, even when unnamed, and he firmly rejects mysticism, consciousness-based interpretations, and the idea that physics is merely about information. Bell's Sleepwalker. But Bell's most disturbing insight isn't technical, it's psychological. Physics moves forward, experiments match theory, predictions hold. Yet all this happens while ignoring foundational confusion. Physicists work confidently in the dark, without distress, without protest. Not only are they asleep to metaphysical problems, they are comfortable in their sleep. Bell calls them sleepwalkers. We might go further. They are philosophical zombies. Bell's Sleepwalker versus philosophical zombie. Let's be precise. A philosophical zombie behaves just like a conscious person, but has no inner experience, no qualia, no awareness. It reacts with instinct, but without meaning. Bell's sleepwalking physicist is similar, technically excellent, but metaphysically indifferent. They follow equations, master tools, but ask no questions about the reality behind them. Metaphysics versus psychology. In short, the zombie lacks inner psychology, the sleepwalker lacks inner metaphysics. Both succeed by instinct, but neither understands the meaning of their success. Bell's critique is not of their results, but of their silence. Bell's rejection of consciousness-centered interpretations. Bell strongly rejects all consciousness-based interpretations. Reality is not created by observation. Measurement does not require a mind. Physics must remain mechanical, objective, and mind-independent. He draws a powerful analogy. In early quantum theory, wave and particle were reconciled, both exist. Similarly, system and apparatus must be treated as one, not artificially divided. They are both quantum systems, part of the same reality, and by analogy, mind and matter are also not fundamentally distinct. Bell rejects mind-body dualism. Consciousness and the universe are not two realms. They are aspects of one physical reality. Conclusion. Bell stands for realism and stands against anti-realism, dualism, idealism, and mysticism. He extends the unity of wave and particle to system and apparatus, and ultimately to mind and matter. For him, physics remains an unfinished project of unification, not halted by failure, but by the quiet confidence of sleepwalkers. If you found these ideas thought-provoking, feel free to share your reflections in the comments. Let's continue the conversation and stay awake to the deeper questions that physics still leaves unanswered.